In this video, we will learn how to segment tumor portion in a stomach or the kidney portion. So here you can see the tumor is having a particular segmentation part, particular reference, and on the basis of classification or image annotation, I have and means describe all these identified all these tumor sections. You can have more classes like cancers and the maybe patient other stone, any other disease symptoms, but as of now we are going to inflate the tumor part only. So for this I'll open the, you can see this is the collab part, and I'll open a new collab new notebook in order to run that part. So this is my I'll perform all my code in the Google Colab, and in the Google Colab you will have to mount uh, your your Google Drive. So for this, what I'll write from Google.colab, I'm going to import my drive. All right. So from drive, I'm going to mount my actual drive, and so where I'm going to mount this inside the content and G drive. All right. So I'm going to run this code. Right. So this will run my entire code and the entire section. All right. So obviously it will take time, few time taken process, because this is the first time I'm going to import, and make sure you have disk available, gigabyte available in yours. So I'm going to connect to Google Drive, and then I'm going to choose an account which is my account, and then if it is given a verification code, then I'm going to send that verification code. So this verification code will be sent on my registered mobile number. Then I'll I'll check that code and revise, put that code inside my verification code. All right. So here the code is 205744. Then I'll click on next and then have the authentication process. So it will also apply for the allow. So I'll give the allow, and then you can have the content there. So meanwhile I can write the another code, like what is the current location, or I'm going to import another library like import operating system code. So on the left hand side you can see gradually it will pop up your drive link, and then I'm going to clone that git. So what is the git? I'm going to clone that. I'm going to use Google. For here I'm going to use Google 7 GitHub link. This is the official website where you can have your Google code, and this is the git code. You can download the entire code, YOLO official version 7, all these models, training, testing part, but I'm using the git command here to explore inside my Google Colab. Right. So I'm going to copy that code and going to put that code here. I'm going to clone that code here and just print here. All right. So if you will see that my gradually it will show my drive here, and I'll have git clone. All right. So once I have cloned that site, so what I will do, I'll use if not os dot path dot exe. exist. If doesn't exist, then I'll create one path here. So what I'll give the path content slash G drive, that is my G drive link, and then inside I'll give my G drive, and inside my G drive, so you can have, now it's showing here, so you can have my G drive is just here, and I'll copy, you can copy this code from here also. Okay, so from here also you just copy that code, copy that path and paste it here. So inside my drive, and I'll create one more, like aim is new folder I'm going to create, and inside this aim I'm going to create YOLO v7 training. All right, so this is the code, and I'm going to hit here, and inside this I'm going to create os dot make directory. I'm going to create this directories, and inside this directory I'll give the path. So this is not the path, so this is the exact path location. I'm going to create that location, dot c, and going to put it here, YOLO v7 training. All right, then I'll move this path, move my directory inside the given path, right? So inside the given main, I'll go content slash, so currently it's inside the content slash and YOLO v7. You can see this YOLO v7 folder. I want to keep this folder inside the aim folder, aim and then YOLO v7 training. So this code will perform that path. So if not, so exist exist. All right, so okay, so once it will be executed successfully, you can see your code is just successfully, and by using this code clone, I just extracted all these commands, all these files, all these models on my drive. So you inside the YOLO 7 folder, you can see all these stuff is there already there. If not, you can find the YOLO v7 inside the YOLO training mail. I'm having YOLO v7, and all these stuff is there inside the YOLO v7 and all right. So now it is created aim folder there, new folder I have created YOLO v7, YOLO 7 training, and YOLO 7 path is there for everything. Everything which is shown here, that is just extracted here using this clone. I have created that clone here using this path. All right, so now I'm going to, what I'm going to create, I'm going to check my path. So I'm going to get into the, what is the my current path, so that is ls. So what's the current location of my, so this is G drive and simple data. So I'm very above the code, and I want to get inside the location of YOLO 7 folder. So this is inside the G drive, inside my drive, inside aim YOLO my training. Path is too long, so I'll create that path, and inside this path I'll just get v7. So v7, YOLO v7 is the name of my folder where all these YOLO 7 entities and notable boost is stored there. So I'm going to see that content G drive, this one. So my current location is now G drive, inside my drive aim YOLO v7 and training YOLO v7. So I'm just inside the v7 now. All right, so suppose I'll write this ls code again, list my directory. So you can see all these YOLO means all the GitHub YOLO v7, and drawing the attention of YOLO v7 code is just here. All right, so now we are inside the YOLO v7. Now what I will do, I'll just create the git reset, I'll reset my hardware devices or my the official code. So this is just check 100% out file done, and you can see memory leak is there, no difference, and then you can have the particular values. Now I'm going to create, now I'm going to install all my prerequisites. So I will use install -qr and the requirements txt. So requirements.txt file will install, requirement.txt will install all my prerequisite library. You can see the base library, it should be matplotlib lib library, must have the version 3.2.2, numpy 1.18, torch version must have this one, CUDA version might support for the login. So many stuff is there, so you can install one by one all these libraries files in your using pip install and this one. But I'm using this command. This command is directly installing all these stuff over there. All right, so pip install qr requirements.txt. So I'm going to install all these stuff. All right, you can see this is just installed and this is just written over here. All right, now I'm going to, okay, now I'm going to extract the data set from robo flow. All right, so how can I extract that robo flow? You can see this is the my data set, this is my robo flow. So how you can get that robo flow? So I'm having robo l type robo flow for data set and labeling, or you can say roboflow.ai. So you flow.com, you will check this site, right? This one, you just RoboFlow, give your software the sense of height, view few images, computer vision model. You can train your models, and then first I'm going to sign in. So first you will provide your credentials over here. I'm powering the kidney part and kidney segmentation. So I'll have that part over here. All right. So I'm going to create one more library, like create new project. So just creating new kidney images, and license you can choose any one. Object detection box, you can have single label classification, instance or not for supervised learning, but I am taking object detection here, so I'm going to take. So what will you project? So I'll project will detect tumor inside the MRI. I'm going to create that public project. So now I'm going to direct all these files and all these stuff will be there. So you can have images, or like say suppose dataset, kidney dataset, and then test dataset and my images. You can see my images are here, and I can choose or is more than one file at a time, and then I click here. You can see it's already there, and when you will click only one image, it will inflate the segmentation part. Suppose I am having this part is as a tumor, so I'll create tumor here, right, and save enter. Right, you can choose the next file. Suppose this is the, you can have polygon tool also, like this one, this part is the tumor portion, hit enter and just save enter, right, and so on. So likewise you can create so many images, and then coming back to my old projects, because this is the process I can choose, and then coming back to the projects again, and then here you can see I had already defined there. Then you want to export start learning this, it's not showing because I have completed all my 5 so I'm going to export that. You can show download code, and I'll select YOLOv7 PyTorch version. You can select the lower version, but as of now I'm using YOLOv7. So you need to you have to got to leave off old versions. Now I'm going to use YOLOv7 PyTorch. So this is going to select show download code. So showing download code, you can copy this code here and just copy C and paste it here. That's it. So first library, so first code, going to first code will install RoboFlow prerequisite library. You can see it's just already satisfied because I had already installed all these prerequisites, and I'm have already basic libraries there. And further to our code conversation, in the last video we have seen that how to extract this. So just you need to restart runtime and click yes, and you can see over here that your collab library is going to initialize. So meanwhile I change this name, kidney, using YOLO v7. Right, so now it's a have been restate, and now I'm going to restate extract my data set. And you can see this kidney segmentation is already here, not here as of now inside the YOLO v7 folder, but once it will be successfully executed, so you will be appearing, the folder will appear over here inside the YOLO v7 folder. So key role in enforcing the dataset over here, you can have the direct key API key over here. So meanwhile, it's going to appear inside the certain library. So what I'm going to here, I'm going to import one my weights. So I'm going to vget. So coming back to the vget library, and you can have the v7 YOLO v7 and test images and the average performance and any other means batch size, 32 average time, and so on. So I'm going to copy this code. Okay, just refresh so that yes, I'm going to copy this code again. So copy link, and using this vget, and inside this code I'm going to copy paste it. So I'm going to run that code again. So yes, inside the v7 do I have the data set? Yes, so this is new v7 point, and one more point, or the basic installation and the person will I'll train, that is the transfer learning for my custom data set. So YOLO v7, I'll again copy the link and use the command the get and codes and just hit training and run this code again. You can see previously it was not there, means like YOLO v7 training, YOLO v7 v7 point is not here, but gradually it will show here, it will appear here in few seconds. So meanwhile, okay, so let's check where we are. So I'm going to use, ls cwd. All right, oh sorry, so this is ls, I'm going to use this ls. So G drive continuous segmentation. Okay, so maybe my path has been changed. Segmentation here. Okay, so this just get inside there here. No, so I need the correct path. Okay, so I'll click here, cut C, and RoboFlow, and I'll click code and just v7 again, change the directory. Okay, now extract dataset again inside the YOLO v7 folder, and then I'll vget again this my dataset, means my predefined mod means weights, and then again this folder. So you can see inside YOLOv7 I'm having YOLOv7 folder and having YOLOv7 point, YOLOv7 training point. Both the points are now inside the YOLO file. Now I'll check that ls point. Now v7 YOLO v7, and again you can see kidney segmentation 2 folder is now appearing inside the folder. So inside this kidney segmentation I'm having two folders, train and validated. So train is again having images, respective images. Like if I click any image on there, so this will show the kidney image or the stomach image, and I'll click the labels there. So these labels are respective text files for the dataset. Now I'm having valid again. So this is the image file again. So this is going to take the validation part. So I'm having different dataset over here inside the valid folder. So image, valid, train, and then kidney segmentation. Okay. So after this, just once I have downloaded the training set, so I'll click on YOLO v7 where it is inside the CFG, and inside the I'll click on training. I'll click on YOLO v7. You can train in any other part folder, but I'll take this YOLO v7 YAML file. So I'll change this number of classes. If you have two classes, two annotations for tumor stone, you can have NC colon 2, but as of now I'm having one class. I'll change it NC1. Now I'll click over here, then I'll click the data folder where I'm having Coco YAML. So I need to change few changes over here, but I'm not going to change that. So I'm going to upload my data file folder, and inside the data folder I'm having data YAML, and just click here. So inside this data YAML, what are the contents? I can delete all these stuff. First three lines I don't need. I can delete the third line also. I don't need. I need only training dataset path. So inside kidney, so just I'm inside the YOLO v7, so I don't need to give the entire folder. So inside this YOLO v7, I'm having this kidney segmentation. Right? So can you see that kidney underscore segmentation? So inside this kidney segmentation, I'm going to copy that path, and inside this part V, and I'm going to delete all my stuff in still YOLO v7 because my current location is v7. So I don't require to give the all these stuff. So kidneys and then train. So this will provide all the training images. We are having few images, so I'll give the few the number of n images. So it's not required because it's just comment over here. So I'll copy that part, C, and then provide the valid images PLID. All right, then number of classes 1 again, and I'll remove all these stuff here, whatever the written over here. So many classes will be there, you will have to remove as per your choice. Number of classes 1, and that is tumor, so I'll give the 1 over here and just save this file. After this, once I have completed this file, so I'm going to inside training, going to import that training custom YOLO v7. Right, so this will train my entire, so I'm having so many parameters. So for this again I'll go to this part, and I'll have this image instances. So transfer learning training. Okay, so here I am having that code. I'm going to copy that path and just paste it here. So I don't require the lower one, so I'll delete that, and again delete this one. So I'm going to put this one train.py, and workers is equal to date, device is equal to 0. So device is equal to 0 is by default. So device is equal to it is by default CUDA, right? So by default CUDA, if you can have device we can have device is equal to CPU, then it will have by default CPU processor, your CPU processor. So make sure you have changed the runtime. Is it not run? So you can have the GPU, you can save the GPU and then save the default folder. All right. So so CPU will have the part and then you can have CPU part. So now workers 8, device 0, and then I'll have batch size. Let's say I'll have batch size 16, or I'll have CFD Coco instead of Coco. I'm having that data.yml and then img 640 640. Why I'm 640 640 taking? Because YOLOv7, this one YOLOv7 says if you are using this model, so you need to have test size of image test of 640. If you are using YOLOv7 600, then your image must have 1280. So this is the 640 into 640. I'm using YOLOv7 here. That is the path there. It just disappeared because I just changed the runtime. No, not necessary. Your folders will be there. Then weights, again I'll keep the weights here. So weights, where I can have the weights, you can have YOLOv7 dot pt. All right, and then name of the then hyperparameter is optional, you can delete that also, and I'm going to run this command. So it will take time and it will take your processor time. So I'm having that processor time for very quick preview. So for this preview I'm having this part. You can see on the left hand side my folder is going to define here, and my runtime is going to analyze optimizers groups, and my epochs are running, and my first, second, third epochs, and you can have the facilitating part. Once you can have the workers is equal to 8 and 6, you can certain outcomes will follow the certain images, right? So I'm going to move forward. All these epochs will run on your PC. All these stuff will have, let's say 23 29, it's already there. And now I'm going to run this. So this folder will have, so once epochs 28 29 will completed, you will have your outputs inside the discrimination has overshadows the traditional ways of these epochs of this custom data set. So once these epochs 29 upon 29 will collect, then we will evaluate custom YOLO R detector performance and so on. All right. So with Paraman reference, I want to bring to the kind notice that this will be the points where we will have. So now you can use the start tensor board, and the tensor board part will perform there, and then you can have detect runs experience. So inside the experience run, and inside the run, inside the train, I'll have exp3. So these are my previous files, but you will have experience 3, and all these best models, best point will have are stored there, and initial points are stored there. So I'll choose the best point, best weights, best output. I'll provide the valid image path, and you can see this the detect part. So once this code will completely executed, so you will have the output images inside the deploy folder. On the left hand side you can see. So that will drop the certain images in the certain folders. You can see the images are already there. If you want to show the folders, then you have import globe, ipython display, images display, and the globe particular experience 7. So you can see the folder path. So I have given over there experience 7. You can change your folder current experience, and all the images will show. So as of now, exp is not having any image, it's not showing any images there. So you need to give the correct folder. So you can see the current images there. If no path is showing, no, you can change the confidence level. So instead of confidence level 0.1, I'll have the 0.01, 0.5. I'll check for different one, right? So for different experience 2, I'll have the images and I'll have the inflating part over there. So the value it needs to create is above just about the confidence level it's having. And see, so you can see so many tumors are detecting because my confidence level is very low. It's 0.01. So you can see 25 tumors, 20 tumors. So this is very means very overestimating the part. So the certain outcomes will follow. The confidence level will define the certain outcomes of your output. So let's have confidence level 0.1. So I'm going to run this code again. So check what will be the my output, because it's totally depending upon your custom data set, your training part. So finally I am having experience 6, and inside this experience 6 I am going to check my images. So inflating the particular images, you can see my tumors are detected now. Some few wrong detections are also there, but no worries, you will increase the data set, increase the accuracy, you will have more tumor data set, more library over there. All right. So this is the part of segmentation. This is the part of annotation part. You can have the free logo over there, and drop me a message if you are having any difficulties, any at any level, at any part. If you are having any annotation part problems, you can call me. You can drop me a message with paramount reference. I want to bring to your kind notice. Thank you so much.